Yes, my friends, today is the day that we build Minecraft in React 3 Fiber. And I would like to mention before we start that what you see behind me here is our starting point. So we already have a player and the ground and some sky and so on. But if you want to have a more thorough explanation from the top about React 3 and React 3 Fiber, there is a video on Barely Coding called Building 3D Worlds in React that you could watch before this if you want to. But if you want to keep watching this one, let's jump right into the code. So this was actually just a create React app start, and this is the app.js file, and here you can see what we have so far. We have the sky from Dre. We have physics from useCanon that is wrapping the ground and the player. And then we have the positions coming from this top level, so it's easy to see how things relate to each other and so on. So we keep position as a prop that is being passed in. And for the gravity, we have -30 in the y-axis. We have an ambient light and a spotlight to get some nice shadows. So let's look in the ground component. The ground has a texture that you saw in the intro. It has a grass texture. It is a repeat wrapping with the same size as the actual ground plane. We have to rotate it 90 degrees because if we don't, then it's vertical. We need it to lie down. And we're using usePlane, the hook from useCanon that makes this plane a physical object that can react to physics. And of course, like I mentioned, we also need to wrap the ground and the player in this physics component also from useCanon. So that's it for the ground. For the player right now, all we have is the camera from the use3 hook. We represent the player with a sphere also from useCanon. We set it to dynamic so that it will react to gravity. And then on every frame, we take the camera that we get from 3, and then we take the position of the player. This is a ref to this useCanon sphere. We copy that position onto the camera so that the camera will be in the middle of the player at all times. We also, apart from these two components, we have two hooks. One is a useInterval hook. We're not using it yet, but I'm planning to use it for saving the world every 10 seconds so that you don't lose your beautiful Minecraft creations. And the second hook is a useStore hook, and here we're gonna create the state of our world using Zustand. We also have some images for the different textures of the blocks. I think a good way to start this would be to create our state. So we will call our state hook useStore, and that will be a call to Zustand's create. And this one takes a callback function that returns an object. And as an input to this callback function, we get set from Zustand. So now we can model our state here. We will need to have cubes, that's a given one. We'll set it to an empty array. We will need to add cubes, so we'll have a function called addCube. We'll also need a remove cube. And apart from cubes, we also, since we have multiple textures that we're going to use on our cubes, we need to store what the active texture is. So we'll call that texture, and default, let's have wood as the default one for now. We need to change the texture, so we'll have a set texture function. I mentioned that we're going to save our world, and that could be a function on the state as well. There we go. If we have stored the state of our world in our local storage, then we need the initial state to become whatever is stored in the local storage. So I'm going to create two helper functions here called getLocalStorage and setLocalStorage. So the cubes will come from local storage if there is an entry in local storage called world. So we'll say get local storage world, but if we don't have that, we'll just set it to an empty array. When we call save world, we will call set, and inside set we have another callback function where we receive the state. So now we have access to the whole state. So here we do set local storage, key was world, and what we want to store is state.cubes. So let's think about what each cube will look like. It will be an array of objects, and each cube will have two keys, one for the position, which will also be an array with X, Y, and Z, and the second one will be the type. For example, wood. So here it would be like 0, 0, 0. So let's think about what do we need to know about a cube that's being added. Well, we need to know where to place it, so we need X, Y, and Z, and we also need to know what type it is. So here we can also do a set. We receive the state, and we return a new object. And for the cubes, we need to take all the old cubes, so we spread state.cubes, and then we add our new cube, which has position, X, Y, and Z, and the type. There we go. That should add our new cube to the array of cubes. When we're going to remove a cube, all we need is X, Y, Z. We don't care about the type. We just want to filter out the cube that is being called to be removed. So we take in X, Y, Z. Again, we call set. We receive the state, and we return state.cubes.filter cube, and here we need to check cube.x not equal to x, or cube.y not equal to y, cube.z not equal to z. So what this line is doing is saying that if any of the coordinate does not match, then keep it, but if all of the three coordinates match, then filter it out. So this should allow us to remove a cube if we pass in three coordinates. Setting of the texture, then we just need to receive the new value of the texture. Texture. Same thing again. We get the state. We just return an object where texture, like that. I think that should be it for the state functions. So now we actually added one cube on the default state, and that's good that we can use that one to when we build our cube component to see if this one single cube will be rendered in the middle of our world. Okay, now we have the state out of our way, and we can continue with more fun stuff, visual stuff. So let's create a component that represents one of our cubes. So cube.js. Okay, and this cube is going to be a physical object that we can stand on. So we will use box from use canon. And we want to receive the position and the type of cube from the props. And we can take in the rest of the props in the props variable. What we should return from this function is a mesh. And we want the cubes to be able to cast shadow, so we'll add the cast shadow prop to the mesh. And now let's call useCanon. So we get a reference to this box from useCanon, so we'll call useBox. And here we pass a callback function. And it should return an object, so we'll wrap it in parentheses. And this object will have type static because these boxes in Minecraft or cubes in Minecraft, they're not falling around, they're just static where they're placed. We get the position, so we'll set the position in here. And we can spread the rest of the props in here as well, so that if we pass something into the cube, they're automatically passed into the use box. And this should be a string. So now we have a reference here. We want to put this reference on our mesh. So ref is equal to ref. Let's add our geometry here, a box buffer geometry, and we attach it as geometry, like that. Okay, now we have a cube that takes in position and type and that renders itself out. So now we should be able to place a cube, position is equal to we need to import the cube here. I will pass the type to be wood, but we're not using type yet. So there we go. Now we actually see our cube, but it is below ground almost. So we'll set the cube position to be 1 and it will come up. So our next step is to add some texture to this box. So we'll go back to the cube and I prepare this file that just has all the textures. And where we want to use all the textures, we can use import star from textures and we'll call it textures. Now we have all our textures in this textures variable, and we can see that all of these exports are now in the same object. So if we want to access a texture, we do it by these names. And those names should be the same as we get as the type here. But since we have 6 sides to this cube, we need to do a little loop here. We'll create an array of length 6, and we'll map it. We will just use the index, so I'll do underscore and then the index. So what we return from this map for each side is a mesh standard material, and it should have some props. Attach array as material. Map is where we send in the actual texture. So we take from our textures variable, which is an object, and we want to look up the type. So this will, for example, be wood, and then we would get that texture. Key, we can just use the index for this key. I think that should be enough. Let's see if we have a wooden box. Let's see, line 15. Oh, we need to return this, so we can do a parenthesis instead. no wood yet. Let's see why. I'm passing in type wood, and in textures we have a texture called wood. Attach array map textures type. Okay, I had to instantiate this array with a spread, and then it worked. Okay, so now we have a nice cube here. We have the right textures. We can see that we do in fact have a shadow. But right now we can't even move towards it or look around it or anything, because we still can't move. We just represent it by a sphere and we drop on top of the ground. So we should figure out how to look around and to move around using the WASD keys. I would like to create a hook that the player can call, where they would get an input of where to move. Essentially is the keyboard telling us to move forward, backward, jump, and so on. So let's create a hook called use keyboard controls, use keyboard controls.js. To start out with, let's first make a mapping between the key code and the action. And the action will just be described by a string. For example, we make a function called action by key. So you pass in the key and you get back the action that that key triggers. So we can do an object in here called keys. So for example, key W, which is how you move forward in first-person shooters. Move forward. So this we can call anything. This is just for us to understand what each key is doing. So I'll just type this out real quick. There we go. We have forward, back, left, right, and then jump with space. Let's create the same thing, but for the different textures. And I will put those on the digits 1 to 5. Function texture by key. There we go. So I put dirt on 1, then grass, glass, wood, and 5 gets the log. So it's the same as the actions basically. Now let's create our actual hook. Use keyboard controls. Export const. So inside this hook we will need some state to keep track of things. Let's import useState from React. So we'll create a piece of state called movement. Movement, set movement, useState. And this piece of state will be an object. And here we use the very same wording that we have here. So let's remove all the keys. And we'll set all of these to false. There we go. Now we have a movement piece of state here we can use. So for the texture, we don't need to have any internal state, because we can just call the store to change the texture for us. So let's import the store. Import use store from. So here we can just, we want that function that we created called set texture, because that's what we want to call if we get a digit between 1 to 5. We just want to change the texture. So use store, and then we can give it a callback function that gives us the state. So then we can return what piece of state that is the function set texture. So that it's state dot set texture. So now our set texture function in here will be the set texture function from the state. Actually, we don't even need to have it in an array. We can do it just like that. Now we need to import useEffect, because now we're doing the key event listeners. useEffect. So the most important thing is that we do document add event listener, listen for key down, and then we need a function, so we'll call it handle key down, and we'll have another one for key up. And since we're adding event listeners, what we should return from our useEffect a function that cleans this all up. So we'll do the same thing, but we remove. Okay, so now it's time for us to create the handle key down and handle key up functions. We get an event. So we'll first check if the key that we press down is a movement key. If action by key, e.code. So if we come into this if statement, that means that we did click a movement key. Then we can call set movement. We get a callback there where we receive the state, and we return an object from this where we spread the previous state, and one of the key codes or one of the keys has changed and it's now pressed down, so we know that the action by key e.code, that one should be true. So we keep the state as it was, but we know for this value, which will be one of these keys, it should be true. So this will handle all the movement keys. Let's also handle the texture keys here. If texture by key e.code, then we know that we want to call set texture, and then we can just go through find the name of the texture represented by that key. So we'll do texture by key e.code and pass that in, and then we should be good to go. So now let's handle the key up. So this should be very similar to this one. I mean, we don't have to react to a texture key coming up, we just react to a texture key going down. So if we have a movement key, we just have to flip this to false. And that should be it for... Oh, we also have to return our state for the movement. So we return movement. So what we will get back is this object every time. And if we click a key, these booleans will... If we press down WASD or space, these booleans will flip to true, and we will get, the hook will call us with the new values. So now we can actually use this hook inside our player. Import use keyboard controls from hooks use keyboard controls. So now we can destructure out these, move forward, move backward, move left, move right, and jump. Equals use keyboard controls. So now we have values that will change based on if we click down our keyboard by using this hook. So let's try that this actually works. If we console log move forward, for example, forward, Now I will go to the browser and I will bring up the console, W, forward true, and when I release, forward false. Pushing down, releasing. So that's great, it all seems to work fine. So what we want to do is when we receive these inputs, we want to move this sphere. So we also get an API back from the sphere as the second return in this array here. We can continue in our use frame here. Let's have first a representation of the direction, and we'll use a vector for that, vector 3, since we have x, y, and z. And we can think of it as one force going forward and another force going to the side. So I will call the going forward, I will call it front vector. I will represent that with the vector 3 as well. And we'll give it some values. So for the x, it will always be 0, because that's the sides. For the y, it will always be 0, because that's up and down. But for the z position, that is back and forth. So here we want to look at the move forward and move backwards values. And we can think of it like that we take the force going forward and subtract the force going backwards. So if we hold front and back at the same time, they cancel out to 0, because otherwise weird things could happen. So we can do it like this. If we get move forward, we add 1 to this, and then we subtract 1 if we're also pressing moving back. So if we have both, we get 1 minus 1. Otherwise we get 1. If we're only pressing move back, we get only minus 1. So how would we do that? We do move forward. If that one is true, it's 1, otherwise 0. And then we take minus, move backwards. If that one is true, we take a 1, otherwise 0. It should be as easy as that. And then we do the same for going to the sides, but then it's actually this value, the x one, that is going to change. So we'll set this one to move left and this one to move right. And we'll change the name to left or side vector. This one should of course be 3, and this one should also be 3. Okay, so now we have 3 vectors, one for direction, one for the front and back, and one for the sides. Now we need to do some weird calculations on these to figure out how to set the velocity of this sphere. So we'll take this empty direction vector and we'll create a vector from the side vector and the front vector. So we'll do sub vectors, front vector, side vector. So now we combine them. Then we do something called normalize, which is basically you make a vector to have the length 1, which is a very common thing to do, because now we're going to multiply it by our speed constant of the player, which we haven't created yet. So we'll do multiply scalar, and we'll call this constant speed. And let's create this constant, const speed, and we'll set it to 6. And the final thing we need to do is apply Euler. So the Euler is the most, I hope you can see there, the Euler is the most complicated one of this, because that is taking a rotation and a force and seeing how much that this force affect that direction based on the offset in rotation from that direction. That's as easy as I can put it, I think. So we create a vector from the front and side vector, we normalize them, we multiply them, and then we see like where am I looking compared to this force. So the final step for us, apart from the jumping, is to actually apply this direction to our sphere. So we'll do api.velocity.set direction.x. The front and side is just for the x and the z axis. For the y we want it to stay the same. So the x we get from direction, y we don't know what to do yet, but for the z we also get it from the direction. So the y needs to just stay the same. So what we can do is that we can use a ref, useRef. We'll create a ref here called velocity. I'll say useRef. I will set it 0, 0, 0. So we can use this one to keep track of the y velocity. So we can do velocity.current.1 because it's the y, the middle one. And we want this reference to the velocity to follow the velocity of our sphere. So to get that working, we create a useEffect. So in here we do API, that's the sphere, dot velocity. And then we subscribe to it. So here we get a callback, we get the velocity passed in. So then we can do velocity, which is our ref, dot current is equal to v. So this will keep them tied together. And then the dependency for this useEffect is api.velocity. We need to import useEffect as well. Okay, so let's see if it actually works. I'll press W. Okay, W takes us backwards. S also takes us backwards. A takes us to the left, and D also takes us to the left. So we're probably close to getting it to work, but there is a bug somewhere, so let's see if we can find it. Is there maybe in the use keyboard controls? Move left, move right. We could console log the whole use keyboard controls just to see that we get the correct keys back. Console log, move forward, move backwards, move left, move right. Okay, let's see if those are correct. So I'll press W, only W became true. S, only S became true. A was also correct. D was also correct. So it's not our hook that is the error, it's probably one of our calculations then. I wonder if I need to have parentheses around these ones. Let's see if front and back works now. Okay, now they work, but they are opposite. So W takes us backwards and S takes us forwards. So that's an easy fix. We just have to do this. And let's add parentheses to these ones as well. Okay, let's see. Yeah, now the sides work. So W forward, S back, A left, and D right. Cool, now we can see the sides of our box. So the final thing in our controls is that we get the first person shooter controls, or it's also called pointer lock controls. So we will look where our pointer goes. Okay, for the first person view or the mouse controls, I will create a new component and I will call it FPV controls for first person view controls. And there is actually an example that we're going to use from the Three.js examples. So I will copy this example. So it looks like this. Import pointer lock controls as pointer lock controls implementation. And what you do is that you extend and pass in an object with pointer lock controls implementation like this. Just following an example here. So we need to import extend, and it did it automatically. So now we can do export const fpv controls is equal to, here we get props. So we need a reference to the camera from use3, and let's create a ref to controls. So we need to import useRef, React, useRef from React, and use3 from React 3 Fiber. We need to have a useEffect because we're going to start these controls when we click on the document. useEffect. So here we do document dot add event listener, and it's a click, and the callback function. Here we're gonna call our controls dot current dot lock. So if we click on the document, then we lock our controls to the camera. Let's import useEffect, and this only needs to run once, so we put an empty array as the dependencies, and now we return pointer lock controls impl, and it needs some props. We need a reference to the controls. We need to pass in some args. So we need to pass in the camera as the first property, and the second should be the GL DOM element. So we can get the GL from use3, and then we can do gl.dom element. That should be it for this component. So now we want to render this component inside the player. FPV controls from FPV controls. And we'll just render it here. FPV controls. So let's see if we broke our game. So now when I click on the screen, it should lock to my mouse. Oof, this is so cool. So now I can change rotation, and when I press W, it will move according to my rotation. So now I can explore the different sides of the cube. That's super awesome. I can look at the sun and so on. So we've come a long way. We have a working movable player. We have a cube component. So now we're going into the more Minecrafty stuff. So one big part of Minecraft is adding cubes to other cubes. So we need to have like a hover state on a cube so that you can see if you're actually looking at a specific cube, and also what side of the cube we are looking at, because what side we're looking at will determine where we place the next cube, if it's on top or on the sides. So let's go into the cube component and create a hover state. So first we import useState. We'll call it hover and set hover, and we'll initialize it just to null. So now let's go down to this mesh, and for the hover we need to do on pointer move. We get an event, and we also want to stop the event propagation, because we want this to affect just one of the cubes and not all of the cubes that are behind the cube that we're actually looking at. So we'll do e.stop propagation, here we want to set our hover. So in this event we get something called face index, and for each side of the cube there is actually two faces, because in these 3D worlds everything consists of triangular polygons. So each square side actually has two triangles on it. So to figure out the index of the face that we want to set, we need to divide it by 2, just because there is 2 per face of the cube. So we round down, so we do math.floor and we do e.faceindex divided by 2. So now if this was correct, we have set the correct face index of the cube that is being hovered. And since we are mapping the different faces here, and this index and this face index lines up, we can set a different color to the side of the cube that we're actually looking at. So we'll say color hover is equal to the index. We set it to gray, otherwise we just set it to white. So if everything works, where we look, that side of the cube should turn gray. So I hover here. Yes, it's working. So you see, the side that is being hovered is turning gray. So that's super cool. So now we can, and if we go into pointer lock control, we can actually figure out where we are looking and where we are to place the next cube. So that's a great step forward. The next step for us could be to make the cube even better. We could hard code in the store a few more cubes that have some different textures. So if we go into here where we hard coded our wood cube, we could create a few new ones. We have 5 different textures, so we create 5 cubes. One more. So it was wood, dirt, grass, glass, and what was the last one? Log, I think. I mean, we also have to loop from the store these cubes instead of just hard coding it inside the app component like this. So I added them now into the store, and we need to place them properly. I mean, we could do 2 for one of them. This one we could move a little bit to the side, and this one as well. I think now they're not in the same place and they have the different types. So now let's go into our app component, and instead of just hard coding one cube, we will get the cubes from the store and we will loop them out. So we will import our store hook. Const cubes is equal to useStore. Here we make a callback function that receives the state, and we just return state.cubes. So now we should have our array of cubes. So let's do a loop here. Cubes.map cube. So we return a cube, and for the position we pass in cube.pos, and for the type we pass in cube.type. Or was it texture? Let's see. It was texture. Texture. Let's see if I used type anywhere else. Type. This should be texture. This should be texture. Now we've used texture everywhere. Perfect. So let's go back to our loop. Texture is cube.texture and position is cube.position. So I think now it could actually work that we get these 5 cubes, all with different textures looped out. Texture is not defined. Texture, there we go. Let's see. Yes, and these ones also need to have 1, 1. There we go, now we can see them all. So we have this one does not work, and the hover is sticking. So to fix the sticking of the hover color, we need to add on pointer out. We just set hover to null. That should fix it. Yes, that's great. Let's figure out I think it's the log texture that is not working. Did I call it log? I called it woo. Log. Great, now we have the log as well. One thing that I want to fix for the glass color is that this glass should have transparency. So let's add transparency to the glass. So it should not be so hard to add some transparency to the cube if the texture is glass. We just add an opacity prop here to be texture equals glass. If that one is true, then we set it to 0.7, otherwise we'll set it to 1. And for transparency to work, we also need to set the prop transparent to true. So now let's see if we have some transparent glass. Yes, now it's see-through. Really cool. Okay, now let's go into creating or adding new cubes. So we need to import our useStore hook in the cube component, and we want to import add cube, remove cube, and the current active texture from the useStore. Add cube, remove cube, and the active texture. We'll call it, since we already have texture here, we'll call it active texture. And how we get things from the store we already know. I'll type it out real quick. There we go. And the add cube and remove cube should be on clicks, but I think we can have remove cube if we hold down a key and click. And of course the texture just comes from the keyboard hook. So this piece of state we only need to consume in this. So let's add an on-click method here. Again, we want to stop propagation. So the first step is to figure out what side of the cube was clicked. So clicked face. And we'll do the same thing as we did for the hover. Math.floor e.face index divided by 2. And we do have a reference to the box that represents the cube here. So we can get the XYZ from that box by destructuring it. Ref.current.position. So here we need a bunch of if statements. We can do if clicked face 0. We call, we can do add and remove at the same time by doing e.alt key. Was it an alt click? Or like was the alt key held down when we did the click? If it was, we do remove cube, XYZ. Otherwise we do add cube, XYZ. And we need to pass in the texture, which is called active texture, the one that we got from the state. So now I just need to duplicate this for all the 6 faces. Okay, so now I added all the faces, and for remove cube we want to remove the cube that we clicked on, but for add cube we don't want to place it in the exact same place. We want to place it to the side or above or below the cube corresponding to the face that we clicked. So that's why I have to do x plus 1, x minus 1, y plus 1, y minus 1, z plus 1, and z minus 1. So I think we can actually try this out now. So let's go up to the cube, place one here. Oh, and we do get a wood cube. So now we can actually try out our texture switcher. So I press digit 2. So now I should have switched to a different texture. And that was grass. Press 3. And that's the glass. 4. It's wood again. Is that right? 5. Log. Let's press 1. Dirt. So now we can actually place cubes. So that's super cool. So let's try removing of cubes. So I look at this one, I hold down Alt and I click. It does not work. Is there something wrong? Oh, this does not look correct. This should return an object. Cubes is equal to the filter cubes. Now maybe remove will work a bit better. Click all, hold Alt and click. No. Ooh, I think I know what I'm missing. I need to destructure position from the cube. It should be position here. Position. Position. Now maybe. Still no? Ah, wait, it's not an object, it's an array. Now maybe. I forgot to add a return to the clicked face here. That's why sometimes things were behaving a bit weirdly. Now, maybe now. Yes. Let's get rid of these initial cubes now. So we'll start from a clean slate. Now let's add the ability to set our first cube, because then we're not clicking on a cube to create another cube, then we're clicking on the ground. So we'll add an on-click to this ground mesh. So again we want to do e.stop propagation. And here we want to get X, Y, and Z from the actual click. So we'll structure that. And we can do object.values of the e.point. And then we do a transform of those. So for each chord, we return a rounded up of that chord. And then we can do add cube X, Y, and Z. And now of course we need to import also the store. Import use store from hooks use store. So we also need to pass in the cube. We'll call it active texture. Active texture. Okay, let's try it out. Let's click the ground. And it works. We do get a cube. And we can remove it. Now let's figure out how to use an interval to save our world every 10 seconds so that we don't build something cool and then lose it. So we need to also get our save world function here from the store. State.save world. And now we want to import another hook for the interval function. Use interval takes a callback function and how often it should run as the second argument. Let's do it every 10 seconds. And in here we want to do save world and pass in the cubes. And we can do a console log saved. So now let's see if we place a cube. We wait for it to say saved, and now I try to reload. And it worked. We have one movement that we haven't finished yet, and that is the jump. So let's see if we can jump on top of this box. So we are back in the player, and as we can see, the jump keyboard control is not yet used in this file. So let's go to the end of our use frame hook here. So we'll say if jump. And we also need to check if we are standing on the ground, because otherwise we can jump over and over again and go higher and higher. So we'll do math.absolute value. We'll take our velocity of the sphere, which is the player. Velocity, so this is the velocity ref that we have connected to the sphere. Dot current 1, which is the y, velocity in the y direction. To fixed, we'll round it to 2 decimals. We'll check if this one is smaller than 0.05. That means that we have very little speed in the y direction. If we get the jump key and we're not moving fast up or down already, we do api.velocity.set. For the x, we want to keep our velocity, so we'll do velocity.current 0, which is for the x. For the y, we want to add a bunch of speed, so we'll add 8. And for the z, we'll keep the same. So similar to the x, we do velocity.current 2. Okay, now we can try out our jumping. So I will press space now, and it works. Let's see if we can jump up onto this cube here. Cool. And one more thing that we should add is to import nano ID, so we can set a unique ID to every cube. Nano ID from nano ID. Then we can do here key is nano. Hopefully that should work. Yes. Let's build something. Okay, I'm done. So I will link to the code base in the description, and if you want to start out like I did in this video, there will be a dev branch that you can use for that. I will also deploy the game somewhere, so you can just go to URL and try it out. And if you enjoyed this video, then give it a thumbs up and consider becoming a subscriber to the channel. I hope that you learned a lot by watching it and that you had fun. So until next time, take care, bye.